Alright, so first we're going to look at the first quadrant. So we draw a random line at the first quadrant. And let's just assume that the angle is 45 degrees. Because at 45 degrees, this line can have a coordinate as 1 and 1. Alright. What will be the sine, cosine, and tan for sine for 45 degrees, which is in the first quadrant? Sine 45 degrees would be opposite by the hypotenuse. The opposite is this one, which is 1. And the hypotenuse, which is this one, you can calculate root 1 square plus 1 square, which is root 2. So sine is 1 over root 2. We can find out cos similarly. Cosine 45 degrees would be equals to adjacent by hypotenuse. The adjacent is once again 1 and hypotenuse is 2. And tan 45 degrees is just sine over cos, and that would be equals to 1 because sine and cos are equal, so they will cancel out when they're divided. The main thing to notice here is sine, cos, and tan are all positive in the first quadrant. So the rule that we can get generally is in the first quadrant, all are positive. Moving on to the second quadrant, we draw another line, and this one is 45 degrees from the left side, or from the negative x-axis. But we always count angles from the positive x-axis. So this is going to be 180 minus 45 degrees from the positive x-axis. Because this is 45 degrees from the negative x-axis, once again we're going to have coordinates of 1 and minus 1. Now, let's find out the sine of 180 minus 45 degrees. Now notice that 180 minus 45 degrees is in the second quadrant. So all the angles that we're going to find out is for the second quadrant. Sine 180 minus 45 degrees. Once again, this is going to be opposite by hypotenuse. The opposite is 1. And the hypotenuse is root over 2, as we found out before. Cosine of 180 minus 45 degrees is going to be adjacent by hypotenuse. Now notice that the adjacent in this case is negative 1. So we are going to write negative 1 over root 2. Tan of 180 minus 45 degrees is going to be sine over cos. Because these are the same, they will cancel out to form 1. However, it's going to be negative 1. So we write negative 1. So the principle that we notice here is that in the second quadrant, sine is positive, cos is negative, and tan is negative. Alright, now on to the third quadrant. Once again, we'll draw another line in the third quadrant, and we will draw the line such that it makes 45 degrees below the negative x-axis. However, since we're always measuring angles from the positive x-axis, the angle is going to be named as 180 degrees plus 45 degrees. And we're going to find sine, cos, and theta for 180 plus 40, sine, cos, and tan, sorry, for 180 plus 45. Once again, we have to determine the length of the sides that we're going to use for the sine, cosine, and tan. This is going to be -1 as before, and now this is in the negative y-axis, so it's going to be -1. All right. So let's start with sine. Sine of 180 plus 45 degrees. This is going to be opposite by hypotenuse. The opposite in this case is -1, and the hypotenuse is -1 squared plus -1 squared, which is √2. Then we'll find cos of 180 plus 45 degrees. Cosine is adjacent by hypotenuse, so this is going to be -1 over √2. Finally, tan of 180 plus 45 degrees. Remember, tan is sine over cos, and since sine and cos are the same, and they both have negative signs, we are essentially going to have +1. To summarize, in the third quadrant, we saw sine negative, cos negative, and tan positive. All right. Now let's move on to the final quadrant, which is the fourth quadrant. And like before, we'll draw another line. This line is 45 degrees below the positive x-axis. And we are always counting positive angles counterclockwise from the positive x-axis. And therefore, this angle will be named 360 minus 45 degrees. Because in a full circle, we have 360 degrees. And right now we're trying to find out this angle. However, since we are always calculating angles from the positive x-axis in a counterclockwise direction, we have to use 360 minus 45, which is this bigger angle. Now that that's done, once again we have to determine the x and y coordinates. Like before, since the angle is 45 degrees from the line, it's going to be +1 and -1 in the negative y-axis and +1 in the positive y-axis. Now let's find sine of 360 minus 45 degrees. We know that sine is opposite by hypotenuse. The opposite in this case is -1. Hypotenuse is √2. And we get that by +1 squared plus -1 squared √2. Now let's find cosine of 360 minus 45 degrees. Cosine is adjacent by hypotenuse. The adjacent is +1 in this case, and hypotenuse is √2. Finally, we have tan of 360 minus 45 degrees. Remember that tan is sine over cosine. In this case, both have the same magnitude, so they're going to cancel out, but they have different signs. So the negative sign is going to remain, and we're going to have -1. To summarize, the fourth quadrant has sine negative, cosine positive, and tan negative. Take some time to go over all of the previous quadrants, because now we are going to write the summary. So what we've seen this far is, in the first quadrant, we have all positive. Highlight the A. In the second quadrant, we have sign positive. Highlight the S. In the third quadrant, we have highlight the T. And in the fourth quadrant, we had cosine positive. Highlight the C. To make this easier to remember, we can write A, S, T, and C. And then remember this as C, A, S, and T. The reason why we are going counterclockwise is for you to remember that we always measure angles counterclockwise from the positive x-axis. This is very important to remember whenever you're finding sine, cosine, or tan for any angles. So remember, cast cos positive in the fourth quadrant, all positive in the first quadrant, sine positive in the second quadrant, tan positive in the third quadrant.